Hey guys, welcome back. So till now we have learned all the four types of linked list, the operations that can be performed on them, and the time and space complexity required to perform those operations. Hope all these ideas were clear. Now before we conclude this chapter, it is very important that we compare all the time complexity for the same operation between an array and a linked list. This will give us a very good idea about which are the areas where array is good and which are the areas where linked list is favorable. So let's get started. Now before we start this video, I will highly recommend please pause this video right now and cover this column number 2 and column number 3. Try to answer all of these questions on your own using these two diagrams over here. If you are unable to answer them, then of course you are always free to look up column 2 and 3, but please try to answer them on your own. This will be a great exercise for you. Fine, I hope that you had paused this video and would have been able to answer most of them. Now let's go through all of them one by one. So the first operation was create. So when we are creating an array, it is a constant time operation. Similarly, for a linked list, it is a constant time operation. When we are inserting a new node at the first position in linked list, it is a constant time operation. Whereas if we are inserting a value in the first cell of an array, it is again a constant time operation. Similarly, if we want to insert a new node at the last position, in case of linked list, it is order of 1 operation. For an array, if we are storing a value at the last cell, it is a constant time operation. Now insertion at a kth position. In this case, array wins over linked list. So let's say if we want to insert a value at the third position, then in case of an array, we can directly go to ARR 3 and insert our value. So this will take order of 1 time. However, in case of an linked list, if we want to store a value at node 3, we have to start from node 1 and keep traversing till we reach node 3. So this will take order of n time in the worst case, because we might have to travel almost entire array in this case. Now the next operation is deletion from first position. So in case of linked list, it will be a constant time operation. Similarly, from an array, if we want to delete a value from the first cell, it will be order of 1. Now deleting a node from last position. In case of an array, we can directly go to the last cell and delete the value. Similarly, in case of a linked list, if it is a double linked list, then we can perform this action in order of 1 time. But if it is a single linked list, then it will take order of n time. And the reason is that we have to loop starting from first node till the second last node. Now deletion from a kth position will always take a constant time in case of an array, because we can directly reach the cell number. But in case of a linked list, it will be order of n time, because we have to start a loop from first and go till the location at which we want to delete the node. Now searching in an unsorted data will take order of n time in case of an array, because we start from the first cell and keep traversing towards right till we find the number. Similarly, in case of a linked list, it will take order of n time, because we start with node 1 and keep traversing towards right until we reach the node that we are looking for. Now in case of searching in a sorted data, the scenario becomes interesting. In case of an array, the time taken will be order of log n. How is that possible? That is possible using a search called binary search. Now how does this binary search work? Please check the videos titled binary search. But in case of a linked list, there is no such functionality. So again, linked list will suffer very badly here. So it will start from the first node and keep traversing till the last node to find user desired value. The next operation is accessing nth element. So if we want to access the third element over here, we can directly access it via ARR3. So it is a constant time operation in case of an array. But there is no such functionality in linked list. If we want to access node 4, we have to start from head. So it will take order of n time. Now traversing will take order of n time in both the cases, because in both cases we have to access each and every cell or node, so that will take order of n time. Now the last operation was deleting entire array or linked list. So to delete an entire array, it is a constant time operation, but in case of a linked list, we have a little twist. If it is a single linked list, it will take order of 1 time. However, if it is a double linked list, it will take order of n time. So I hope that you have now understood that for a given operation, how is array different from linked list as far as time complexity is concerned. So that is all for this video. In the next video, let's talk about some of the practical uses of linked list. Thanks for your time. See you in the next video.